Welcome everybody, and thank you for joining me on Conf42 Cloud Native. I hope you're enjoying all the great talks from all the awesome speakers. Today we're going to be looking at two revolutionary technologies. We're going to learn about GitOps and see how GitOps is done using Flux. And we'll apply GitOps patterns across multi-cloud resources by using Crossplane. I think there's no better way to learn than hands-on. So most of this talk is going to be a live demonstration to see these cool technologies in action. But before we do that, let's take a quick look at the theory behind GitOps and the tools we're going to be using. Before we get started, I want to tell you a little bit about who I am. My name is Leonardo Murillo. I'm founder of Cloud Native Architects, a consulting firm specializing in continuous and progressive delivery, site reliability, and continuous security. I'm CNCF community organizer for the Costa Rica chapter, CNCF speaker, and co-chair of the CNCF GitOps working group. I'm also DevOps Institute ambassador. I love to connect, I love to network, and share ideas around these subjects that I'm so passionate about. So please do connect with me. Find me on LinkedIn, Twitter, or look me up on my personal blog. You can see the details now to reach me on the screen right now. We're going to be looking at some technologies and patterns today that are very revolutionary, so let's briefly talk about them. My focus today is to actually demonstrate how these work, but let's get a good idea of what we're going to be going into. The first subject that we're going to be looking at, the first concept that we need to grasp, is GitOps. GitOps is an operating model for the continuous delivery of cloud native applications. What makes it unique is the fact that it's driven by four principles that, to me, wrap its power in four fundamental tenets. The first one is the principle of declarative desired state. There's a fundamental difference between a declarative system, and an imperative system. Imperative means you're given instructions. You're telling a system what to do to reach an expected desired state. GitOps is not about imperative, it's about declarative, where you're just describing in code how you want that system to look like, but you're not specifying which steps to take to get there. Your state, the desired state of your system, now going into principle 2, should be immutable and versioned, which means once a desired state has been pushed and committed to your fork, to your trunk, to your main branch, then it should never change. It represents a static, immutable point in time, and the only way to modify that, to progress your system to a new desired state, is by committing a new version. So it's versioned and immutable desired state. Once new versions of state are committed, there should be a continuous process of state reconciliation, which means agents. This is automated, not human. Agents are continuously validating that what you have declared in your state store, what you have declared in your repository where you're storing your declarations of desired state, is matching that which you're running on your target system. There's this continuous process of reconciliation of state. And the fourth principle means that there should be no other mechanism to interact, to manipulate this target system. Everything that you do, every operation that you perform, should be through code and through declaration. The only way for anybody to be able to manipulate the state of a system is by committing a new version of desired state. But we're going to be looking today at GitOps applied to a very specific area, multi-cloud resources. Multi-cloud resource could be anything from a managed SQL instance to another Kubernetes cluster. So how do we declare those in code? Well, we're going to be using Crossplane. Crossplane is a tool that was created by Upbound and eventually handed over to the CNCF, currently in sandbox state. And Crossplane allows us to declare in code using Kubernetes natives. For instance, custom resource definitions. Crossplane gives us a whole variety of CRDs to create any imaginable resource across most relevant public clouds that we work with nowadays. Has support for Alibaba, Google Cloud, Azure, AWS, even private cloud providers. Gives us a CRD for pretty much any resource that you want to create. So this allows us to declare in code with Kubernetes declarations, Kubernetes manifests, what we want to create in the cloud. But how do we make it so that those declarations in some state store, in some repository, continuously get reconciled with our actual runtime state? That's where Flux comes in. Flux is a tool created by Weaveworks, also handed over to the CNCF, that has recently reached incubation status. And Flux is a tool for doing GitOps on top of Kubernetes. It tracks a repository or a path within a repository and makes sure through operators and controllers that the state of your cluster is consistent with that declared in the repository, and it's not just by chance that it satisfies the principles of GitOps. After all, Weaveworks, the creators of Flux, was the company that coined the term GitOps. So we're going to be using this to reconcile crossplane objects on our Kubernetes cluster to make sure that the desired state of our clouds is always consistent. And now it's the time that we've been expecting. This is what we came here for. We came here to see how this actually operates. So now I'm going to show you how this looks in action. Okay, let's get to code. Let me show you a little bit as to what our setup is going to look like. Since we're going to be doing GitOps, of course, we need a repository. So I've created a blank, brand new repository that you can actually access. It's in my personal GitHub, Murillo Digital, and it's called Conf42 multicloud. There's nothing in here other than a README. You'll also be able to see these two terminals. On this terminal, I'm going to be applying changes to this repository. And the first thing, of course, that I'm going to do is I'm going to clone this repo. And on this screen, you are seeing K9s, which is this really awesome tool. Because you haven't used it, look it up, K9s. Basically showing us what is currently happening in the repo. So here, in the cluster. So here we're currently seeing all pods across all namespaces. That's our setup. This is what we're going to be working with. Step number one that we want to do is we need to clone this repository. I'm just going to go ahead and clone it. Onto my development workstation. And here it is. Got an empty repo and an empty cluster. So we need to bootstrap this cluster using Flux. That's the first step that we have to perform so that from that point forward, we will no longer directly interact with the cluster, rather only through changes to the repository. Luckily, Flux gives us a very simple idea, a very clear idea as to how to get this done. Since our repo is in GitHub, we are going to be using the Flux CLI that you can actually see here how to install on the Flux documentation to bootstrap our cluster. For that to work, we need to export our token and username so that GitHub, Flux CLI knows how to authenticate as us to be able to work with this repo. Okay, this I've already done. So if we look at my terminals, I have already created a GitHub environment, and this effectively allows Flux to know who we are. We're actually just going to use these variables in the Flux CLI command line to trigger our bootstrapping of a cluster. I've already installed the Flux CLI, so if I run Flux here and I run this command right here, I can actually validate that I'm ready to use Flux. The versions of Kubernetes and kubectl that are required pass. Okay, so now I need to run a command that is going to allow us to bootstrap this cluster against our repository. I'm going to show you that command real quick because I have it here pretty handy. And I'll tell you what this is. So I'm going to modify it to match what we have. The name of our repo is Conf42 multicloud. And we're saying, hey, Flux, I want you to bootstrap using a GitHub repository. Me being the owner, this is a personal repository. This is the name of the repo, the name of the branch. And this path is what is going to tell Flux where to store the manifests that it will create to match the runtime that it will run against the cluster and store in the repo, so there is a starting point of consistency in what's in the repo and what's running on the cluster. So once we run this, I'm just going to copy this over and paste this right here. Flux is going to connect to GitHub. It's going to clone the repository that we had already created, and it's going to generate all sorts of manifests and apply them. And here you can see on the right side how Flux has already created multiple controllers, a Helm controller, a customized controller, and others, as it's bootstrapping the cluster so that it will actually be able to maintain consistency of the repo that we're tracking and what it is running on the cluster itself. Now, if we go back to the repository, you'll see how new content is being added here. These manifests that have been created are the declarations that match what Flux just did on the system. So once the cluster has been bootstrapped, now we have a consistent state of what Flux has pushed to my repo and what is running on the cluster. Okay, now we have our cluster being tracked by Flux, and Flux having pushed all the manifests that represent that desired state and is consistent with the runtime pushed to our repo. Now it's time for us to install Crossplane. The fourth principle that we looked at mentioned that there should be no direct manipulation of a target system, which means at this point we will not be doing anything that directly talks to the Kubernetes API. If you look at the Crossplane documentation, the recommended way to install is using Helm. So we are going to be using Helm as well, but not by running a Helm install. We're going to be using declarations. Luckily, Flux allows us to use two different types of technologies to deploy applications. We can either use Helm or we can use Customize. Following the recommended approach by the Crossplane documentation, we are going to be using Helm. But before we can install Crossplane, we want to create a namespace for it. Remember, we're not doing anything directly against the cluster. So the first thing that we need to do is we need to push a declaration that creates that namespace for us when the state is reconciled. I've changed canines to track our different namespaces. So here we're seeing all namespaces. And I have already pulled the changes that Flux added, the code that Flux added to my repo in the cluster's my cluster path. There's a very valuable observation to make around this. When I bootstrapped Flux, I specified which path I wanted Flux to use to store the manifest, which means you can do multiple things. You can, in the same repo, in a single repo, store the state for multiple clusters, as long as they live in different paths. And you can also point multiple clusters to the same path. So you can effectively control the state across a fleet of clusters by modifying files in a single location. Now, the other important observation is that you will want to have some logic behind how you structure your files within your repository. Here we have already a basis for that. We have a specific path that matches one or more clusters. So we'll want to create within that path a directory structure that is also meaningful, that means something to you when you look at it. The default setup that Flux Bootstrap creates is a Flux system subdirectory, which is actually consistent with the Flux system namespace that it creates. So I'm going to follow the same pattern, and I'm going to create a Crossplane system subdirectory where I'm going to be adding all the resources, all the manifests that I want to be synchronized against my Crossplane system namespace. First thing I'm going to do is I'm going to create a directory, Crossplane system. And here I'm going to add a manifest. Now these are good old Kubernetes manifests to create our namespace. Okay, nothing out of the ordinary, just a namespace manifest. What's going to happen now is I'm going to commit this, adding namespace for Crossplane. I'm going to, oh wait, I got to add it. And I'm going to push it to the repo. As soon as it's pushed, we're going to see it here. Now we have Crossplane system. And now this is where the magic starts to happen. Pay attention that I haven't done anything other than pushing this file to the repository. Soon, you'll see here a new namespace show up. The Crossplane system namespace that Flux is creating for us as it looks to reconcile the state. Right now, the desired state of my system is different from my runtime state. It's inconsistent. Flux will make sure that it ends up being consistent by creating those resources for us. Now, this might take a few seconds because of the cycle at which Flux validates what's running, what's available in your state store. So let's continue moving on. There it is. Crossplane system now exists. Okay, so we have a namespace for Crossplane. Now let's install Crossplane. So we need Helm to install Crossplane, or actually we're going to use Helm to install Crossplane. Flux comes with custom resource definitions for Helm applications and customized applications that we're going to use for that. You can look at the documentation in the Crossplane website to get the parameters that we will need as far as Helm is concerned to install this application. Now, again, we're just going to create manifest. So I'm going to create a new manifest here that's going to be called the Helm release. I'm going to copy over a Helm release that I already have available, and we'll walk through it real quick. 1 second. Okay, so in this Helm YAML file, we're going to be adding 2 different objects, both coming from the Flux application. One is the Helm repository. Helm repository is basically a type of resource that specifies Helm repo. The URL on the Helm repo is the same URL that you would use if you do Helm repo add, for instance. This I got from the Crossplane documentation. Then we're going to create a Helm release. Helm release specifies a Helm repository from which we want to get a Helm application, and which name we want to install, which application we want to install. So here we're saying I want to install the Crossplane chart on this specific version, and I'm going to get it from this Helm repo called Crossplane stable. Crossplane stable is the same name that we used here in the Helm repository, and I'm actually telling it in which system this repository has been created. This Helm repository object exists. Again, we don't do anything other than committing this while adding this. And pushing it. And now I'm gonna take a look here as to what we get in terms of pods. Right now we only have Flux system and Cube system. There's nothing running in Crossplane system, but we just asked it to create a new Helm release. Matter of fact is we can even look for Helm release here. Oh, there it is. We have an in-progress reconciliation for a Crossplane system Helm release. This is actually installing Crossplane for us. This is the equivalent of doing a Helm install, except that Crossplane is doing for us because we added a Helm release in the Helm repo manifest. And here you can see that now it says it's true to reconcile. If we look at pods, now we have Crossplane running in the Crossplane system. All we did was push a manifest of a Helm release in the Helm repo that included a Helm release in the Helm repo, and we have a Helm install of our Crossplane system. Just pretty much awesome, right? But now we have Crossplane unable to talk to anything. We're going to look at 2 different types of objects now. We're going to look at providers and provider configurations. A provider is what Crossplane uses to talk to any one specific cloud. There's providers for GCP, for AWS, and for other clouds. And a provider configuration configures that provider given a set of credentials that it will use to authenticate against that specific cloud, and some additional properties. For instance, if we're looking at the GCP provider, we need to configure which project we want that provider to use. So next, we're going to push providers and provider configs. Remember one thing though, that we'll see soon, provider configs also need secrets. Those secrets are actually holding the credentials that the provider is going to use to talk to those clouds with some identity. We're also going to look at those. Okay, so we're ready to install our providers. We're going to go through the same process as we've done already. We're going to declare those in code and push them to the repo. We need to create one provider for AWS and one provider for GCP. On this demo, we're going to be creating a SQL database, a managed SQL database in GCP and in AWS. Since we're going to be talking to 2 separate clouds, we need to define 2 separate providers. We're going to do that by adding a provider manifest to our repository. First, let's add the AWS provider manifest, which is a very simple manifest that we're going to just copy over. And we're going to do the same for our GCP manifest. For our GCP provider, I mean. We create another file. We're going to paste this provider. Now, both providers are basically the same. The difference is the package that we're installing. For AWS, we installed the provider AWS package. For GCP, we're installing the provider GCP package. These are not namespaced resources. They're cluster-wide resources. And they're now available in our cluster thanks to Crossplane's Helm install. These CRDs now are available for us to leverage. So we're going to create 2 providers, one for GCP and one for AWS. We're going to add these 2 files. And we're going to push this to the repo. I'm going to change this here so that we actually see these resources getting created. So we need package Crossplane. We need package Crossplane version 1 provider. Providers. Crossplane version 1 providers. Okay. Here you can see how we have now two providers, AWS and GCP, and now they're both healthy and installed. This means that now we're able to communicate, or we have all the necessary components that we would need for Crossplane to communicate with AWS and GCP, with two notable exceptions. We need to configure these providers, and as part of that configuration, we need secrets. Those secrets are going to include the credentials that we're going to be passing to the provider so that they can authenticate as us with the specific cloud that we're going to be engaging. So let's do that. First, we're going to add those secrets. Secrets, and of course, by the time you see this, these tokens are going to be already invalid. So there's no risk here. But I'm going to show you what a GCP secret looks like and an AWS secret. These secrets basically have, in the case of GCP, the full JSON key as you would create for an identity. So let me show you a little bit what that looks like. This is our GCP secret. It's basically our encoded JSON key. And I'm going to do the same for AWS. Which includes our AWS secret key and secret access key ID and secret access key. If you want to understand how these keys were created, you can look at the Crossplane documentation, which is very thorough. And when you go to install and configure, scroll all the way down, you'll see here how to create the AWS credentials or the GCP credentials. And for the GCP credentials, you will need to create a service account. For AWS, you need an identity with AWS key ID and key secret. So please refer to this URL to understand how to create these secrets. Once we have the secrets created, which we have here, I'm going to add these secrets. For cloud connection. I'm going to push them to the repo. We also need another resource. That's called a provider configuration. And we're also going to need one for each one of our cloud providers. So I'm going to show here secrets. Hold on a second. Here you can see that we have our AWS and GCP provider already available. Now we're going to create our provider configurations. We need one for each cloud. And I'll walk you through what those look like. So first, let's start with the GCP provider configuration. I'm going to just paste it over from here, and I'll show you what that looks like. The provider config kind of object is also made available by Crossplane. There is a namespace for GCP, and there's a namespace for AWS, and a namespace for the other clouds. Here we're basically configuring how we're going to talk to this cloud provider. We're specifying which secret we're going to be using to talk to the cloud. In the case of GCP, which project we want to create our resources in. And that's about that. So let's also create the AWS provider config, which is going to be very similar. In the case of the AWS provider config, we don't really need anything other than just the secret that we're going to be using to talk to the cloud. Secret, which name of the secret, what the key within that secret is, and as you can see, the only difference here is the fact that the API, where this is coming from, is not GCP, rather AWS. We're going to add these two files. configuring providers. And I'm going to push that to a repository. So now we have a secret that we're going to need to talk to the clouds. We have our providers installed and configured. We are now ready to deploy some cloud resources onto AWS and GCP using Crossplane CRDs. Awesome. So let's do a little bit of recap of where we are. We started off with an empty K3s cluster and an empty repo. We used the Flux CLI to bootstrap Flux into our cluster, which effectively put in place all the different manifests in our repo to be consistent with what's running in the cluster. Then we used Flux with its Helm repository and Helm release CRDs to install Crossplane into our cluster. We added providers and provider configs for Crossplane to be able to talk to our clouds, including the necessary secrets for those provider configs to be able to communicate with the cloud. And now it's just a matter of adding resources. And for practical purposes, we're going to provision an RDS instance in AWS and a Cloud SQL instance in GCP. So I've switched one of the screens on our setup just now. And now we're looking here on the right side to a AWS console and a GCP console, specifically the RDS service and Cloud SQL service. So now we want to create our databases. I'm going to copy over, because I have this manifest already ready, the GCP database manifest, which we're going to look at real quick. This is Crossplane. And Crossplane gives us different APIs for the different types of services that are for every cloud provider. So in this case, we're looking at the database GCP Crossplane IO API, and we're looking at a Cloud SQL instance. There's some important values that you're going to want to pay attention to here. One is the provider config ref. This tells Crossplane which provider config to use for spinning up this resource, for provisioning this resource. This is valuable because you can have a single provider, say GCP, but multiple provider configs so that you can use different billing accounts, or you can identify as different users or service accounts or identities within GCP, for instance, and use access controls to limit who can use which. Single cloud provider, multiple provider configs. Here you can specify which provider config to use, as well as pass specific attributes for the provider to configure your resource. So in this case, we're telling it which database version we want to use, which engine we want to use, and which region, etc. Now, there is a very valuable feature of Crossplane, very powerful, which is this write connection secret to ref configuration attribute in this manifest. This allows you to specify the name of a secret in which Crossplane is going to insert the endpoint and credentials for this specific resource. It's going to pull the data from your cloud provider and make it available as a secret within your Kubernetes cluster, which is, of course, super efficient whenever you create resources and want applications to connect to those resources without having to do any manual effort. So I'm going to just do what I've done with all the other manifests that we've looked at today. I'm going to add it and commit it. Adding GCP database and push it. I'm going to show you here on the right side the Cloud SQL console for GCP. Now, this is not instantaneous. It's going to take a few seconds. So while we do that, I'm going to also copy over the AWS database manifest to my repo. Let's look at it real quick while this is refreshing, which we're going to see the database come up soon. And this is basically a very similar configuration to what we saw. The kind of resource is different. Now we're looking at an RDS instance database. The API is different. This is no longer in GCP, this is in AWS, but you'll see a lot of commonality as to how you configure this resource. You're specifying which provider config to use, which is the same thing that we talked about. You can have multiple configurations for, say, AWS, and you're passing to your provider parameters as to how to configure this specific resource, as well as which secret to write the connection details into. I'm going to add this file. And I'm going to refresh here real quick to see if we're seeing the database already. Okay, so we waited a minute or two, and now let's take a look at our consoles. We have our RDS instance already created, matching the spec that we defined in our CRD. And we have our Cloud SQL instance created, also matching what we had in our CRD. Just phenomenal. All it took was adding two manifests or a repo, and we're actually creating resources in our clouds. Now, there was one specific attribute to Crossplane that I highlighted while we were looking at the database manifests. The fact that it stores the connection string, credentials, and other details that you need to be able to connect to the database as secrets within your cluster. So let's take a look at that real quick. This is our previous console, and let's get secrets in the Crossplane system and namespace, where we asked it to store them. Here you can see that we have this AWS RDS PostgreSQL connection and CloudSeq PostgreSQL connection. Secrets, these are the names that we specified in our CRD where we wanted the connection secrets to be stored. Let's look at one of them real quick. We're going to look at this AWS connection secret. And here you can see that we're not going to decrypt it, but we have our endpoint, we have a password, we have a port, and a username. These are the details that have been provided to a Crossplane, that have been pulled from, in this case, AWS by Crossplane, and been used to populate the secret, which now you can use anywhere to connect to this database. It's super powerful. Cool. So we created our resources. Now we don't want to have any lingering stuff there, so let's just get rid of them. How do you get rid of them? Well, you just remove them from your repo. Let's remove GCP database and AWS database because we want to clean up. We're going to get rid of our databases. And we push. Since we're looking at GitOps, this is also going to reconcile, and this is going to destroy our databases. This is also going to take a few seconds, a minute or two, but we'll see these databases be destroyed. So that is the power of Crossplane, using the Kubernetes API to manage your cloud resources, and fully managed using a GitOps operating model, where I did not interact with the Kubernetes API directly at all. And everything that I did is now tracked in Git and represents different points in time of the evolution of my platform. So that is what I wanted to show you. Crossplane and Flux demonstrating the power of GitOps for multi-cloud resource management. I honestly think this is the future of how we're going to operate clusters. I did not interact with the cluster directly at all. And there's auditability, there's versioning, and there's this very powerful mechanism to control and collaborate in managing our platforms and managing our clusters and our cluster fleets. So I hope you found this valuable and exciting. You can always reach me, find me on LinkedIn, you can find me on Twitter. I'd love to show you more. The repo is available for you to look at the code that we worked with today. And I'd like to say big thanks to Conf42 for giving me the opportunity to show you how GitOps and Crossplane and Flux can work together to really revolutionize how we manage multi-cloud resources. Thank you, and till the next time.